Okay, in this screencast, I want to continue our work on geometry and picking up on what we have been doing on congruent triangles. And I just want to go through a congruency proof because there's a little technique involved and they're quite structured. So the first thing I want to do here is just pick up on our four congruency proofs. So I think we've sort of got the idea here, haven't we, that to prove that two triangles are congruent, we've got to use one of these four proofs. It's got to fit into the information we have has to fit with one of those four. So let's I suggested having a look at example point 4 on page 97, which is great, and hopefully you've done that. I'm going to do question 5C from page 99. One of the questions I think in your work requirements if you were doing channel 2 or 3, but for all of you I think being able to structure a congruency proof is an important skill. Okay, so the first thing you do is you have a look at, now in this case we are being asked to prove that each pair of triangles is congruent, and so in this case ACB, this triangle here, and this triangle down here CDE, we're working with those. And alright, so first thing to do is we're not going to start. I can see there's a couple of equal sides here and I can do some things, I'm sure, but I'm going to firstly work out which one of the four I'm going to go with. You know, which one is it? It doesn't look like it's a right angle, but right, let's see what we got. Now I've got a pair of equal sides here. Okay, so that's one. So what else have I got? I know enough about these. When two lines meet like this, I get this pair of equal angles here that form. So they're called vertically opposite angles. So I know I've got an angle there, I've got a side there. So at this stage, you know, I could come up with another side and get side angle side, but I can't say that's equal to that because there's nothing written down about that. So I can't just make stuff up. Right, so what can I say? Is there another angle? Well, I've got parallel lines. As soon as you see parallel lines, usually you can use some angle properties. And I reckon, look, I've got this. This is one of my Z angles, isn't it? My alternate angles there and there. So I'm going to go and start to draw on this diagram now. I'm going to say, right, well, that angle there is equal to that angle there. They're vertically opposite. So I just mess around a little bit and I get all the information I need. Those two angles are equal because they're alternate angles on these parallels. And now, what have I got? Is that one of my proofs? Let's have a look here. I think it's this one here, isn't it? The angle side. Two angles and a corresponding side. Yes, they're definitely corresponding. There'd be no point telling me that those two are equal because they're not corresponding. So it's the corresponding sides are, there's one pair of corresponding sides equal and there's a pair of angles equal, which is brilliant for us. So away we go. See how when I say the corresponding side, they're both opposite this angle here that hasn't yet been marked. Now because that angle is equal to that angle and this is equal to this, right, they're going to be equal, aren't they, from angle sum? But we can also see that they're also alternate angles. The line segment with the two bars, the two little crosses in it, which indicates that those two sides are equal, they're opposite that angle, in this case E, and this angle here. So they're in corresponding positions. They're equal in corresponding positions. Right. Okay, so what are we using? We're using an AAS. So the first thing we do is we decide, we draw on our diagram, we get our game plan in order. This is an AAS game plan. So away we go now into our solution. So I write, in any order at all, I need to write my three equal statements that prove these two triangles are congruent. Right, so let's go about that. No, not A. Let's use the sides firstly. BC is equal to DC. And what we've got to do also here is give a reason for every single statement. Now in this case, we didn't have to use our brains at all, just had to use our, look at that. They're telling us they're equal. I haven't come up with anything there myself, so it's given. It's given to me in the question. Righto. What else do I know? Well, all right, I'm going to use these little X angles next. Now the way to indicate this angle here is using the letters A, C, B, using three letters, A, C, B, and I've got to have a little angle symbol, which is either like that, like a little hat, or I could put it down there. All right, either way is fine. I mix it up. ACB equals, what's this angle here? DCE. DCE, little angle sign on top. And my reason for that, they're vertically opposite. Now it's a little bit of a pain. Got to do a bit of writing, got to get some words in place, But look, we don't do a lot of that in maths. In geometry, we've got to just do a little bit of reasoning. So let's just go with it. Now, what else did we want to use? Well, it's up to me. I only need one more angle. I'm going to go with this angle equals this angle. So that's angle CDE. CDE equals this angle up here, ABC. ABC, little angle sign there. Now they're alternate angles. That's what I've got. I've got alternate angles. Righto. So now I've proved they're congruent. I've used the AAS. So my final statement is, therefore, I can triumphantly state that triangle ACB is equal to triangle, little triangle symbol there, DCE. Okay, now what I should do is I should write the vertices in the right order. So A and E should be in the corresponding spots there. So I probably haven't done that quite right. So my matching my A should be E. So I should have E there. Matching my C should be C. That's fine. And matching my my B should be D. So I should write it as ECD. You see there that I've just got in the corresponding positions the angles that correspond to the diagram, if you see what I mean. Righto. And in brackets I just put A, S. And there we've proved it. Okay, so that's how to lay out a congruency proof. Okay, the next section is on parallelograms and using some proofs in parallelograms to prove some properties. Just going to do a couple for you here, just getting you in the idea, getting you in the swing of what this is about, and then we can go on into 2C and we can do some more proofs. And now whenever we do proofs now, we're going to use this structure here that I've just been through. The three equal statements with reasons, therefore triangle, blah, blah, blah. Right. So we're going to use that in the next bit on parallelograms. Now parallelograms are huge. Rectangles are parallelograms, so are squares, so are rhombuses. They're all parallelograms. Okay, so we do quite a bit with parallelograms. So I'm just going to say, all right, I'm going to give you a parallelogram. Here we go. I'm going to tell you that this here is a parallelogram. If I tell you it's a parallelogram, I'm just telling you that those sides, both pairs of opposite sides, are parallel. Now let's prove the property that both pairs of opposite sides are therefore equal. Okay, and we're going to, in order to do so, I'm going to put the diagonal in. So I've got two, what am I trying to say? Two triangles, A, B, C, D. I'll call the vertices. Okay, and what I'm going to do now, so remember we started with the blue. We started with a parallelogram ABCD. Now I'm going to prove that ADC is equal to ABC, and therefore, as a result of that, I'll be able to say that AD equals BC. But at the moment, I don't know that. I'm going to prove it. So here we go. What can I say? So which of the proofs are we going to use? Right. So what do you know? Because these parallel lines, I'm going to have these angles again, aren't I? So I'm going to have this angle here equal to this angle here. That's true. That's a Z, isn't it? And I'm going to have. Am I also going to have that angle there equal to that angle there? That's correct, isn't it? Now I can't say this side is equal to this side. I don't know that. Remember, I'm proving the property that the opposite sides of this parallelogram are equal. So maybe I need to put that at the top here. My aim is to prove opposite sides of a parallelogram are equal. Right, that's what I'm trying to prove. So I don't know that. I can't use it in my proof. Okay, so what can I say? Well, I can't use that, but I can look at this. AC is a common side. It's common to both triangles. So that means I've got two angles in a side. I've got an AAS. Right. So I've got it. Let's go. What should we start with? We can say that. Right, let's go with this angle here. So that's DAC. DAC is equal to this angle here, BCA. BCA. They're alternate angles. Okay, what else have I got? I've got this angle here, BAC. Actually, I've used DAC, which is in this triangle, so I should use, to be consistent, this angle first. So that's DCA. angle DCA, the X angle is equal to BAC, is equal to BAC. Right, they're also alternate angles. Okay, and then we use AC equal to AC. It's the most obvious statement in the world, but we say it's a common side. Okay, so there we go. AAC, it doesn't take very long to sort this out, does it? Therefore, triangle, right, let's be careful here. We're going to ADC is congruent to, did I use the congruent sign before? No, I didn't. I used the equal sign. I hope you were crying out at your computer screens that I was wrong there. That means is congruent to, is congruent to. It's like a, it's an equal sign but with an extra. It means is congruent to. So triangle ADC is congruent to. Remember that means for a shape the same as equal to. Congruent to, is congruent to. ADC is congruent to, what are we going to say? C, triangle CBA. Because C here and A there are the same. Okay, and we've used AAS. So as a result of that, hang on a sec. Let's get back to the point. I've now proved that this triangle here is exactly the same as that triangle there, which means that this side here must be equal to this side here, and this side here must be equal to this side here. So therefore, this is the big statement. This is the clincher. Therefore, AD is equal to BC, and what's more, CD is equal to BA. So therefore, opposite sides, when we're doing some serious maths here, opposite sides of a parallelogram are equal. And that was the aim. Have a look at the top. Prove opposite sides of a parallelogram are equal. Okay, by using congruent triangles, we've managed to achieve that. I'm going to close it out here. There's much more of that to do in exercise 2C, but we'll do that in class. We'll do that in class on Friday. So I'll see you then.